Okay, this video is more practice in the front of your packet for domain and range. This is number 6. I'm going to do A, B, and C. B is up here, down here, and C's up here. So I'm going to start with A. And if I look at this, I see, oh, this is a radical. So I know I have to do some algebra to find the domain. Okay, so before I get started, the first thing I want to do is to kind of sketch what this looks like. And then after I sketch what it looks like, then I can work on the information. So the domain, I can do some algebra, and the range is here. The first thing is when I sketch this, and your sketch should be what it is, a sketch. Make sure you make it bigger than your pinky. This is X and Y. And when I sketch this, I see that it starts here and goes like this. I don't know what this is yet, but I know that's what it looks like, and it does look like a radical would look. So if I want to find the domain of a radical, the cool thing about finding the domain on the radical is you basically take whatever's inside the radical, because I know the radical cannot be a negative number, all right? So that I know that it cannot, well, how am I going to write that? It cannot be negative underneath the radical, especially if it's a even root. So this is a square root, so the root is 2, so it cannot be negative. So I said, all right, I'm going to do 3x plus 7. You take what's underneath the radical and say it has to be greater than or equal to 0, because it cannot be negative. So then I'm going to solve it. Subtract 7 on both sides, divide by 3 on both sides. X is greater than negative 7/3. So now I know, looking at my graph, this is negative 7/3. So it tells you when you do that I know my domain, or all the numbers that I can put into this function, have to be greater than or equal to negative 7/3. So we're going to use interval notation. Because of this line here means it's equal to, I use a bracket, it's negative 7/3 all the way up to positive infinity, because it goes this way, and this is the way of positive infinity. So if you have a radical, there's work that you can do that you can show this, and whatever you do over here is going to actually be your domain, and we're going to use interval notation. Now the range, you can look at it here and say, oh, the lowest y that we go here, and you can turn this sideways if you want, and you can like squish it to the y-axis if you will, but the lowest this goes is right here. It doesn't go below there, and that is when y is 0, and it actually touches it. So I know my range is from 0 all the way up, and this is positive infinity to positive infinity with a parenthesis. So that is the domain and range of that radical function. Okay, I'm going to do C next just because it's here. I'm going to set it up, domain, range. And this one doesn't have a radical or a fraction in it, so I don't have to worry about doing actual algebra, but I'm going to do the sketch of the graph here. Remember, when you do a sketch, make it bigger than your pinky, label your X and Y axis, and do a nice sketch so that it means something, okay? So when I kind of sketch this, it kind of looks like it crosses here and dips down a little bit more. So I actually went and looked at what is the vertex of this to know what my lowest point is, and I saw the lowest this goes is 0.5, negative 6 point, let me see now, what do I have, 2.5. So that's my lowest point, is that vertex. That's going to help me later on. So first of all, the domain is very easy. There's no restrictions at all. I can say I can have all real numbers, so that's negative infinity to positive infinity. All real numbers, there's no restriction. The range, I know my graph is the lowest it goes is here, which is negative 6.25, and it goes up. So I'm going to say, oh, my range is negative 6.25. It's included, and it goes all the way up to positive infinity. Remember, this is positive infinity, and that's how I do my domain and range for, that happens to be a quadratic function. But it could be any function. I just want to make sure that you do the work if there's a radical or a fraction, okay? So let's do a fraction. So I did the sketch on this. I'm going to set it up, domain, range, and I'm going to actually do the graph over here because this is my last one I'm doing for this, and make it bigger than your pinky. And then when I sketched this, I saw that the graph kind of right here, I'm going to put this here. This is an asymptote. And then I'm going to sketch the graph, and the graph kind of looks like this. All right, so that's what this graph looks like. So I'm kind of all set. I see that it's a fraction, so there's algebra that I need to do to find my domain. So in this case, if you have a fraction, you take whatever's in the denominator and you just basically say, that can't be 0 because I can't have a 0 in the denominator. And then you go ahead and solve it, take the square root of both sides. X minus 1 cannot be equal to 0. Add 1 to both sides, x can't be 1. So this must be a 1 right here. That's where my asymptote is. So in this case, this tells you everything you can't have, and this just says I can't have a 1. So that means my domain is everything else. So I can go from, so this is negative infinity, this is positive infinity. I can go all the way up to 1, not include it, and then keep going to infinity. So I'm going to negative infinity all the way up to 1 in union with 1 to infinity. And there's my whole. Notice there's a parentheses there because the 1 cannot be included. The range, again, you can turn it sideways if you want to look at it. It says, wow, the lowest it looks like is going here. It doesn't even look like it's touching because the function doesn't even exist in quadrants 3 and 4. So this one looks like it's going from 0 all the way to positive infinity, but it's not touching 0, so I'm not going to include it. So there's a little practice, one with a radical, one with a fraction, and one that has neither, how you would do your domain and range. So this is number 6, A, B, and C.